In the last part of this unit, we worked out how we could find the derivative of y in the variable x using the product rule. Now in this example, I can still use the product rule because there is a factor at the top and a factor at the bottom. And if I wanted to use the product rule, all I'd have to do is take that bottom factor into the numerator. In other words, in my numerator, I'm going to have 2x plus 1 as my first factor, and my second factor is going to be 3x minus 2 all to the minus 1. We're first going to find this derivative using the product rule. I'm going to write down the rule once again, just so that we remember what we're going to do. The product rule says if you want to find the derivative of the first factor, times it by the second factor, and then find the derivative of the second factor and times that by the first factor. The first factor is my first function, and I call that one f of x. The second factor is my second function, and I call that g of x. Now finding the derivative of this function, the derivative of f of x is going to be 2. Timesing that by g of x, I must times it by 3x minus 2 all to the minus 1. Notice that g of x is a composite function, and so I have to find the derivative first of the outer function, which gives me minus 3x minus 2 all to the minus 1 minus another 1, which makes it minus 2. Still, finding the derivative of the inner function, the derivative of 3x minus 2 is 3, and then lastly timesing that by f of x, which is 2x plus 1. Now I'm going to show you a second way that I could have found this derivative. You can see that by taking up that bottom factor, I changed this function so it looked like two factors in the numerator. But clearly I could have worked with it with a factor in the numerator and the factor in the denominator if I had a rule that could deal with that. And there is. This is called the quotient rule. For the quotient rule, I need to once again identify the two functions. Well, the function that I have in my numerator, 2x plus 1, I'm going to call f of x. And the function that I have in my denominator, 3x minus 2, I'm going to call g of x. When I do the derivative of this function y, but using the quotient rule, I need to do the following. To find the derivative, I say, find the derivative of the top function, times it by the bottom function. Now instead of plus, you minus. Find the derivative of the bottom function and times it by the top function. Unfortunately, that would have been easy if we had had that as our answer, but that's not quite where we end. We still need to put this all over the bottom function, which was g of x, all squared. Let's do this now for the function that we had for y. So finding the derivative of y in the variable x. The derivative of f of x is going to be 2. Times that by g of x, which is going to be 3x minus 2. Remember, it's a minus. Find the derivative of g of x, and that's going to be 3. Times that by f of x, which is 2x plus 1. And put that all over g of x, which was 3x minus 2, all squared. Now you're going to say to me that these two answers look very different, and they certainly do. What I'm going to do now is I'm going to find the derivative of the tangent at a specific x value, and I'm going to substitute that x value in to both of these options, and you'll see that the gradient of your tangent at that x value is going to be identical in both cases. If I pick an x value, and let's say, for example, the x value that I pick is going to be when x is 1, just because that's a nice, easy one to work with. The derivative from the first expression over here, the derivative of the function in the variable when x is exactly 1, is going to be minus 7. All I did, everywhere in this derivative expression, I substituted a 1 for x. That means that the gradient of the tangent on this function when x is 1 is going to be minus 7. If you now go and you substitute in when x is 1 into your second expression for the derivative, you will find that you get exactly the same answer. It means that if I had drawn a tangent to this function so that the tangent touched my function when x was 1, that tangent would have had a gradient of minus 7. So you can see that you could have found the derivative of your function using the product rule or using the quotient rule. But it doesn't matter that your two expressions look different. Your answer must be the same.